Welcome back. And if you said that the best technique to use is substitution, you are correct. We don't have a greatest common factor to factor out. We don't have 4 terms, so we can't use that. Right? This one is okay. You just have to use it more than once. Right? That's fine. There's nothing wrong with that. But substitution would be the quickest way to solve this. So substitution would be a good choice. If you said division, you're okay. That will work too. We'll have to replace the missing x cubed and x with zeros. Okay? And then we would just have to use synthetic division twice. We had to find, well, maybe more than twice, depending on how long it takes us to find each solution. But we'd have to find 2 solutions before we got to something quadratic that we could factor. But with substitution, we can go right to factoring. The reason we can use substitution here is notice that we have 3 terms. And our exponents are doubles. All right, we have a square n to the 4th power. All right, so let's factor the x to the 4th minus 7x squared plus 12, and we'll find our other 4 solutions. All right, so our first step, we're going to let w equal x squared, and that means w squared would equal x squared squared, which is x to the 4th. Okay? Let's move this over just slightly. There we go. Oops, not that much. All right, there we go. It's still visible. All right, so now we will, actually I'll put substitute. We'll substitute. Come on. Sometimes the pen is a little slow here when I'm recording. So we'll substitute w for x squared and w squared for x to the 4th, and then we can factor. Because we'll have something quadratic. Even though it's really not quadratic, it'll look quadratic. All right, so now we have, instead of x to the 4th, we have w squared. Instead of 7x squared, we're going to have minus 7w, and then we will still have a 12 because, well, it doesn't have any w's or any x's with it. All right, so now we'll factor. 1 times 12 is 12. We need 2 numbers that multiply to give us 12, but add to give us our b term of negative 7. And if you say negative 4 and negative 3, you are correct. All right, so we'll replace the 7 with a negative 4 and a negative 3. So we have w squared minus 7w as a group. And, oops, excuse me, not 7. And w squared minus 4w is a group. And negative 3w plus 12 is a group. We'll factor out the w. We have, oops, my w's all funky there. Come on, erase. Probably should put the pen down. Come on, erase, erase, erase. Good people here are waiting to see the end of this problem. All right, so we have w minus 4, and then we pull out the negative 3. We have w minus 4. We seem like we have like an extra little term here. I don't know what the heck that 1 is in there. Probably it was part of my plus sign. And it just got all funny looking. All right, so we pull out the negative 3, and we have w minus 4. There we go. All right, so what we pull out is 1, w minus 3. The repeating w minus 4 is the other. And if you say your answers are 3 and 4, you're wrong, because we have to substitute x squared for w, right? Because we're not solving with w's, we're solving with x squareds, right? So we've got to do a replacement back. All right, so now we have x squared minus 3 and x squared minus 4 equals 0. One of these is a difference of squares, and we can factor. This one here, the x squared minus 4, is just a difference of squares. All right, so that factors to x minus 2, square root of x squared minus square root of 4 times square root of x squared plus square root of 4. And now the last part here, x squared minus 3, not a difference of squares. 3 is not a square. So we can solve using square roots. Solve using, my shadow's blocking me, square roots. That could be a little neater. Sometimes the writing is just a little tougher when I'm recording. I don't know why. Ooh, I was going to make it smaller, but that ain't happening. All right, so I'll just make this part small. So we have x squared minus 3 equals 0. Add 3 to both sides. X squared equals 3. Take, the square root of both sides. I'm thinking ahead. I'll just do it right here. Don't forget your plus or minus there. All right, so I added 3. I've taken the square root. So x equals plus or minus the square root of 3. All right, so that's 2 solutions, right? And then this is a solution, x equals 2. If x minus 2 is 0, x equals 2. I don't know why my 2 looks like that. Come on. Usually I can erase even when I have the pen in my hand, so long as I pick up the eraser. Any day now. There we go. So x equals 2 and x equals negative 2. Whoa. Well, I should have been happy with the way it looked before. Man, oh man. I think the computer's mad at me, or the board's mad at me. I did let the battery run down, and so maybe it's upset with me. You know, it's like hungry or something. There we go. All right, so we have 4 solutions here. 5 solutions. Don't forget our other solution. We have our 5 solutions are x equals 0, x equals the square root of 3, x equals negative square root of 3, x equals 2, x equals negative 2. There they all are. All right, so now we solved this problem here. And later on I'll make this look just a little bit neater, but it doesn't look too bad. Doesn't look too bad. All right, so hopefully that was okay. Ooh, that one took a little while, 8 minutes. Normally it won't take you that long, but if you don't talk at the same time when you're trying to solve a problem, and if you want to fix something, if you don't have to wait for your eraser to work, it'll work out just fine for you. Let's look at the next problem. We're going to choose a solving technique, and then we'll solve. So, which one do you think I should use? Factor using greatest common factor, factor by grouping, division, or substitution. All right, so I'm going to end this podcast. Make your choice on the next page. Don't forget to submit, and then come back and find out. All right, see you in the next podcast.